Welcome to another blast furnace for the month of May. The only difference about this month is it's blast furnace this month is also one of the official Hunter Innovation Festival events. So if you're not aware of that, definitely have a look. There's been a heap of different, I guess, sort of meetup-y style events running. I guess for the last week, last couple of weeks, is it? Yeah. So just wanted to make a mention of that, and that's why also this month we sort of went through the Eventbrite system for a lot of the RSVPing for the event, because that's how they're running it for the Innovation Festival. But for those of you that haven't been before, we actually run this event every month. And this is basically the layout of the event. So it's sort of a three-part event. We have a code section where we talk about usually some sort of software, perhaps it's related to some hardware element, not always. Sometimes it's just purely software or some sort of tech, and we talk about why it's important and why you would care about how to program it maybe. At 7:30, food will come, and we sort of have about half an hour just to sort of network, have a bit of dinner, have a chat, and then after that is when we get hands-on with whatever the tech is. Typically, get a bit of hardware out, or build a website, or have a go trying to create a mobile app, something like that. So there's sort of the three sections, and for this one, I think we're actually, based on the number of laptops I can see, we're going to have enough devices. I got 10 of them to play with this month. But if anyone sort of wants to be across that, I'd say sit around or buddy up with someone that's got a computer and wants to help out or watch it happen. We had about 25 in-person RSVPs on the Eventbrite, so I actually thought I was going to be short of hardware, but it looks like we only got about half of that, if not less, actually in. So this month, talking focuses on IoT, and also from a sponsorship perspective. So Safi, which is my company, actually put a bit of the bill for the pizza and the drinks, and obviously all the resources to keep the event running. And Dashworks Makespace give us the space, and CISP also tip in a bit of money for the food and drinks as well. So that's basically how we run these events and keep them going and make sure everyone gets their drinks and food as well. So from a code perspective, or the tech topic of the night, is we're going to be looking at basically low-cost wireless networks using the Motino boards. So they're built by a company called Low Power Lab, and I'll be presenting that to you guys. So I'll break that down when I start the presentation a bit more. Next month should be a good one. Pretty proficient web developer that works with me called Sora. He's going to show us how he basically very quickly created a professional looking portfolio for himself using a couple of different technologies there, Hugo and Netlify. So we should be able to, in a very short amount of time, build and deploy our own portfolio website during the blast furnace. So that the next blast furnace will be purely software based one in that web dev sort of area. The shirts, you see a couple of guys wearing the shirts around. If you want a shirt, they're $10. Basically, money from the shirts goes straight back into paying for things for the event. And yeah, if you do want to take any pictures or if you want to tag us in anything, they're the social media handles to use. Also, grab the Wi-Fi passwords if you've got your laptop and you haven't got them already. Let's get into it. So I wanted to, actually, on the Eventbrite, we put on the Eventbrite and the meetup. So if you got your laptop out, it's worth jumping on and grabbing this link. Yep. It is, so it is this GitHub link here. And if the other question I had is, anyone here not on the Newy Slack? Okay. What I'll get you guys to do, not that you need it for tonight, but if you're not on it and you're not aware of it, it's basically a Slack channel, but it's I guess all things tech in Newcastle. It's basically the point where all the discussions are had, jobs are posted, people looking for resources. So you got a job board, you got looking for work. Just essentially, I'd say the Newcastle tech community is basically in this Slack channel. So if you're looking to network, if you're looking to get involved more, this is where to go. It's got a few channels. It'll tell you about all the meetups and events that are happening. Lots of cool stuff. So to get on that, I think it's just is it Newy with 3ws.com. You can literally jump onto newy.com and get an invite, and you can just say that you came if it's asking why or how, because basically the reason they got this invite form in there is because they're getting a lot of people from Newcastle, UK, joining the Slack channel. So this is sort of just like a vetting process. It's not to stop you. You're not really going to be assessed or anything, but it's just to say, yep, I was at the blast furnace or whatever, and they told me to get on there. So I do recommend that. But all right, so on to the topic for the night. I've created this. I just created it all in a GitHub repo, so everything's there for everyone's reference. I basically got tonight centered around these little boards. So the boards are called the Motino board, and the boards themselves are basically Arduino clone, but they've got an RFM69 chip built on the back for wireless communication. So why do we care about that? So effectively, when you're looking at IoT, so IoT in essence is typically trying to sense data from the world, the real world, and get it into some form of database, digitize it somewhere where you can do data analysis on it. Maybe it's for alarms, maybe it's for something more long-term, tracking clouds for solar modeling, something like that. So where there obviously data does flow the other way as well. With IoT, you obviously want to be able to actuate things and control things if certain events take place. But in essence, the crux of it is we're trying to get some sort of information sensed from the real world at what we call the ground level and get that information into the cloud. So ground to cloud. Typically, there's three main wireless technologies that actually bridge that gap between the real world and the cloud. So you have the mobile network, so you can transmit the data straight over your Telstra or your Optus, Vodafone, whatever. It has good coverage, especially if you're looking at the Telstra, where they've got your Cat M1 and NB-IoT coverage, which is like 4 times better than the 4G network. But the downside is you have to obviously pay for transmitting data on the mobile networks. LoRa is a fairly popular solution for IoT. I think mainly because it's a free network to use. It does have limited bandwidth, and it is a guideline, but you are told that you should only transmit pretty small amounts of data. It is for fairly infrequent things, but it's free. You do have to make sure that your area is covered. So someone with a gateway has to be covering your area. And I guess the downside of that is free network means people aren't being paid to set up and run their gateways necessarily, unless you've got something like a council running it maybe. But there's obviously the chance that someone turns off their router or something and they might be the only gateway near you. So there's that risk with that one. And then straight Wi-Fi. So you can obviously have all your sensors connecting straight to a Wi-Fi network. Again, this is going to be pretty low cost, but your router needs to be in range of your sensors, which is then usually would have a fixed internet connection. You can have combinations of that, so your Wi-Fi router might be running off 4G, but typically they're sort of like the three ways that you're going to get data from the ground to the cloud. So the Motino boards. Like I said, basically the Motino boards are low cost, and I think I touched on that. I think they're about 15 to 20 bucks Australian. I think that's what I got them for. Low cost, little Arduino. So for those of you not familiar with Arduino, they're a little microcontroller development board. You can hook sensors into them. They have analog inputs, they have PWM outputs, digital inputs. You can use them to communicate with sensors, so you get information into them. And then the beauty of these is they have an RF chip on them, so you can then use them to wirelessly communicate to another Motino. And the concept is you have them set up in like a node gateway configuration, which is this image just here. And the idea is everything you need to maybe sense or control. So for example, in this diagram here, you might have a whole bunch of Motino nodes scattered throughout your house, controlling your lights, measuring maybe current draw on particular circuits, maybe looking at the luminosity so it knows when to turn maybe your outdoor garage light on and off. And then they all communicate to a gateway Motino, which can then be hooked into some method to actually talk back to the internet. The Motino guys, if you actually look on their website, which I've linked in this README, actually have a Raspberry Pi tutorial to set it up, so you can actually flash one Motino with a bit of gateway code, plug it in via USB to a Raspberry Pi, and it starts funneling data. You can configure it to push data to databases and all kinds of cool stuff. But the reason these are cool is if you look at if you looked at these other methods of communicating wirelessly, so these aren't a replacement for those. You still need some way to get to the cloud, whether it be the mobile network via LoRa or via Wi-Fi. But with the Motino boards, you can have, and with the default firmware, up to 255 of these nodes on a single network, and they all go to a single gateway, and that gateway is then the only point that then is leveraging Wi-Fi, 4G, or LoRa. So you're free to use a lot of bandwidth. Basically, you can be smashing data around between these things, and it's all collecting them at the gateway. You don't need, if you had all these sensors that were just Wi-Fi based boards, they'd probably inundate your router with connections. And I don't know if you guys had experience with this, but I certainly know if my router starts to play up after it gets too many devices connect to it. So that's a way to get around that. These actually have excellent range, so you can get them in a 433 megahertz, a 915 megahertz, or a LoRa module built into it. And we're talking 300 to 400 meters open air range. I've looked on the forums. You can actually tweak the radio settings to get probably twice that. So that's a decent radius for your sensor network. You don't need a SIM card per sensor. So if you were looking at something like putting NB-IoT microcontrollers everywhere, you have to be aware that you would have to put a SIM card on each one of those devices. Perhaps you have your NB-IoT micro, just one of them, hooked into a Motino as a gateway, and then all your other sensing is done through your nodes. And you aren't, and they're super low power if they need to be. That's another big advantage of these guys. On top of all that low cost, which is what I'll talk about here. So the hardware themselves, the Motino boards, this is what they look like. Arduino clone with the RFM modules on them. The ones we have here tonight are the RFM 69 HW versions. 433 megahertz is what we're using. So they're low cost, about 15 to 20 bucks. The ones I have here in particular are the ones built in with the USB FTDI chip on them, so we can just hook them into our computers, program them, and off they go. But you can buy them even cheaper, where they actually don't have the USB connector on them, so actually program them with just like an FTDI adapter, and then you can just sit them out in the field or whatever you need to do. But I think it's the difference between 15 and 20 bucks. So you can program with the Arduino IDE, and we're going to be using a slightly more professional of the Arduino IDE tonight called Platform IO, which works with VS Code, and their libraries and examples are really well documented. So if anyone wants to play with some wireless boards, I would recommend I did a lot of home automation in my house with them, so I had all different lights and garage doors and things basically hooked into these, so they just controlled relays. And then I had one of them hooked into my Raspberry Pi, talking over serial, and then the Raspberry Pi was then the conduit back through to the UI. I didn't actually plumb it through into the internet fully. I just needed a web interface to control it with. But that's the concept. From there, you could forward it through to whatever you wanted to, really. So let's have a look at the software. There's a bit of setup here. So for those of you with laptops, if you want to make sure you got these things in place, it'd probably take 10 minutes for us to get the setup going. So step one is you can either clone or download this repo if you manage to find it. So you can just go up here, and you don't have to clone it, but if you've got a Git desktop app, or just using Git CLI in general, and you can jump on clone it. Obviously, it should be publicly available, but you can just download the code as a zip as well. So we'll need the code. The code is all there. There's two branches because I've got a couple of challenges in here that I thought we could have a crack at. If you do want to also grab the solutions, or if you just want to grab the solutions one and maybe not peek at it, I don't know, I don't really care. But there's one branch with basically empty challenge files, and another one with the code filled out. We're also going to need to get VS Code. So just jump on. I don't know if you're running Windows, Mac, or Linux, but it's all there. I'll just run through it just to get a feel. Is everyone going to get connected to the Wi-Fi all right? See what happens if I just install it, even though I've got VS Code running here. Hopefully this doesn't break my VS Code, because that will make me sad. Yep, all good. Then there's also the Platform IO plugin is what we're going to use to actually program these boards tonight. If you follow that link, it literally shows you how to do it. Open VS Code, search for the IDE, and install it. I have it installed, but if I was doing it, this is how I would do it. And it's this one here, and then that actually says installed. I also have put in the repo, probably for for future reference, just there's a link to a video there on how to run that, but it's all pretty self-explanatory. The instructions there do a pretty good job of that. And the only other problem I hit is the virtual COM port drivers I had to install on my computer to talk to these boards. So if you've played with Arduino and stuff before, you may not need these, but on the laptop that I was at least building this presentation on, I didn't have them. It's certainly on this laptop here that I use for work, but I was playing with it on my personal one. I mustn't have had the drivers, so I did have to go and look this up. And on Windows, there is just a nice little setup executable here. You just click it, run it, installs them. You're done. If I actually click that. So that's all it takes to get those going. It's not, they're not meshed. I think you can mesh them, but the examples aren't there. So I don't know how straightforward it is. I've never meshed them. And the examples I'll be going through tonight aren't mesh. It's just all nodes talking to a gateway. I think with the LoRa chips, they do some kind of meshing. I'm just not using the LoRa ones. I found a diagram actually, just when I was sort of getting things ready for the slides, which I thought was interesting. See if I can find it again. Yeah, I found this. This was one that I found. Yeah, so this guy, so he had used the Motino boards, and they were LoRa nodes in a partially connected mesh network. So it looks possible. So I'll have a quick chat about Platform IO while I'm here. So VS Code's the IDE we're using to program in. If you're not familiar with VS Code at all, it's becoming one of the more popular, if not probably the most popular IDE for development in general. It's free. There's platforms, there's plugins for nearly everything. You can do it. It's really great for web dev. This Platform IO makes it great for low level, like microcontroller stuff. I must admit I'm a fan. But what you would have added is the Platform IO plugin, which will appear down here. It looks something like this. And it has a home screen, so you can hit open. This is kind of what it looks like. I've got that little sidebar there. So effectively, the Spark Notes, or the interesting things about Platform IO is you have to create projects. Once you create projects, they get listed in the project section. Then from there, you can add libraries for the Arduino boards or whatever you happen to be using. So if I actually type in Motino, there's this guy Felix Russo. He's the guy that does a lot of the development for the Motino boards, and so he's got the RFM69 library and the Low Power Lab library, and they're the two libraries we use. And effectively, to add them to a project you create, you click on it and hit add to project, and then ask you which project, and off you go. But lucky for everyone, if you've got the repo, well, I'll step through what we're going to do, but I've done all that. I've set all these projects up for us with the libraries and configurations just to save us some time. I will talk about how to configure them, but the crux of it is you won't have to do that. So what you need to do, just to check, has everyone got VS Code and Platform IO going? Awesome. Effectively, all we need to do is, once you've downloaded that code from GitHub, there's a workspace file in there called bfiotws.code-workspace. Just need to double click on that, and that will open up VS Code in the project for us. So it looks something like this. Double click on it. It'll open up. Now it takes a couple of seconds, so Platform IO kind of kicks in and then does things in the background. So it takes a little bit for Platform IO to sort of get its engine running, but once it's there, it's there. The other thing I just want to make sure, if you've got the board, Motino boards, you can plug them in and just make sure that they get detected as COM ports. Talking directly to Windows now, so if you are running Mac or Linux, there might be another way to figure this out. But in Device Manager, mine's being detected as COM5. If you don't have anything there, then that's a COM port driver problem, and we just need to install those virtual COM port drivers again, perhaps. If you haven't already done it, then you need to do it. So in the little bag I gave you, it's effectively the Motino with its antenna, so you can straighten that out. And I've given you 2 jumpers. I think we'll only need 1, but it's effectively the cheap way I have accomplished push button. So we're gonna do a bit of push button action, but it'll just be literally pushing it in and out of a socket. There also, note on your bag, you've got a number. So we are going to be talking on the same network here. So to keep everyone's own devices unique, use that. We're going to use the number on your bag as a node ID, which we'll talk about when we're having a look at the first part. So everyone see the device as a COM port? So the first little bit of code that we're going to do, it's called the TXRX Blinky. So it's kind of like almost like the hello world for these wireless boards. Effectively, what the code's going to accomplish is I'm going to be the sender and everyone else is going to be the receiver. And then I'm happy if you want to pair up and take it in turns of being sender and receiver, but for the initial test, I'm going to be the sender. And what we're going to do is I'm going to wirelessly send a button press, and that button press is going to toggle the inbuilt LEDs on your individual devices. So to do that, we have to all get our receiver board set up. So all you have to do is if you've got the workspace open, I'm hoping it looks like this. And under the source folder, there should be a main.cpp file. And we'll talk through this by and large is the example code that the Motino guys provide, and like I said, it's pretty good. If you're interested in looking at the example code, it is part of this project in the .pio library dependencies. You can go into the RFM69 and there's examples there. And this is where you got things like the Raspberry Pi Gateway code that I was referring to earlier, Pi Gateway Basic, the TXRX Blinky, which is, I've slightly modified it, but that's what we're doing first. And then nodes and gateways, which is what we'll get to second. It looks like there's a bit going on, but it's not really that complex. So the main things are up here, and this is what we need to have a look at. The sender. Now I have to test this, but if not, I'll do it individually. I believe if I make the sender ID 255, it'll broadcast to everyone. We are looking at the sender code. So I'll take you through. This is the code that I'll have on my device, so less important to you. So I'll just brush through that quickly, and then we'll go to the receiver code. We always have to establish a network ID, and we'll just be using 100. That's the default. The receiver, I think I got that backwards. The receiver will be your devices. So in your code, when we have a look at that, you'll be changing this to the number on your bag. And I'll basically put numbers on the bag just so everyone has a unique one. And you have to specify here whether you're a sender or receiver. You can obviously just put your node ID, but this is kind of set up as a bit of an example setup. This line here is where you actually define what kind of RF69 chip you have on. We're using for the 433 megahertz chips, and an encryption key. So all this wireless comms will actually be encrypted with this key. The key has to be 16 characters. That one did catch me out when I first started playing with these, even though it says it just there. So the serial board that's just what we talked over the serial monitor, and I'll show you how to open that in a second. A couple of declarations for the LEDs that we're going to toggle. Again, I'm brushing over this, is less important, but it's basically an interrupt base button press. So when the line goes high, it will fire an interrupt function that'll then consequently send a message. And there's a little blink function as well for blinking the light every time the button is pressed, so I can visibly see that I'm triggering it. The setup for all these Motino boards pretty much the same. If you're using the HCW version, which we are, then it sets it to high power. Otherwise, it won't set the high power, obviously. If you have an encryption key, it says, okay, we're going to use the encrypt part of the radio library and ATC. So all that's enabled, and it just sets all those things up. Same with the pins for toggling the I/O. So this main loops here is probably the more interesting thing. Monitoring now I think this is actually the main event flags, which are, just based on the interrupt. So it's basically sleeping this until we press the button. This, if the button's pressed, toggle some LEDs and then it does send the string high to all your receivers. Some code here for this stuff here is probably going to be more important than the node and gateway, but it is here in the example as well. Check if something was received. So if something's sent back, and basically display it. Tell me who it was from, the sender ID, the RSI of the person of the radio that sent it, and the data. It is also all the radio comms does sort of like a acknowledge request pairing as well. So it does make sure that the message, you can check if your message was successfully sent or received. Pretty much the crux of this is that, we're going to be toggling a button, and the most interesting code is pretty much just, for the reference of this demonstration, is just here. If I can... We're going to toggle a button. It's going to, if the LED state, this is also in the receiver code, but basically you're going to get a message every time a button's pressed, and it's just going to alternate the LED. So part one, receiver. This is what you'll be flashing to each one of your devices. Go into source, main.cpp, and set your receiver ID to whatever's on your bag. So mine is 1. That is pretty much all you're going to have to change. Once you've done that, hit Control S to save, or you can go File Save. Now down here, and I have got it pictured on the GitHub repo if you need to refer to it later, down the bottom here, these buttons are where we're doing all the checking of the code, building, uploading, and the serial monitor. So what we can do is each one of these projects is set up as an environment. That's sort of how I'm using Platform IO. I'm not sure if it's the most correct way to handle multiple projects in a workspace, but it works. So just here you can see environment Motino part 1 sender. We actually want to make sure that that is part 1 receiver. So now that's actually going to load and build the source that's in the part 1 receiver folder, the main.cpp there. So as a test, just to make sure the code is running, once change your receiver ID to whatever's on your bag and hit you verify, the little tick, and then I'll just go through and tell you, yep, success, the code does build. I'll be interested to see if anyone's gets some sort of errors there. So if that verified okay, then you can do the, I should be able to do it actually. I'll do it on mine, and I actually have to go back and flash mine, but should be able to hit the button next to it, the arrow, which does the build and then also uploads. And you'll see the green flashy light as it's uploading. And once that's done, it'll look very uninteresting because not a lot's going to happen right now. So what basically is going to happen next? It'll take a second, but then hopefully those lines disappeared this time or not. So like this guy's got a red line, that one there. What you can do is try this. You go into PIO, open project, then navigate to wherever you've got my source code from GitHub. Source, you click on, so we're doing part 1 receiver now, just click on that folder and hit open part 1 receiver. And what you're able to do from there is once that's open, you can actually go into libraries, Motino, and basically you can add both the RFM69 and the low power lab libraries to that project. So you just click on them, add to project, and then part 1 receiver. If you do that for both RFM69 and, I'll bring this down for now, RFM69 and low power lab. If you add both of those and then hit, and then maybe reboot your VS Code, it should pick them up. So what I'll do while we're waiting for that is I'll just flash my sender code. Now I think 255 should send to everything. That's untested. So yes, low power lab library. So they're the two libraries, RFM69, low power lab. They're actually not included in they're actually removed from the git ignore the libraries. So actually for this, I just included them, hoping that we wouldn't have to reinstall them, but. Yours is good? Yeah, but I don't believe my stuff. In VS Code, make like yeah. So yeah, if you can, yeah, flash them with the part 1 receiver code, the main.cpp in there. Again, make sure that your receiver ID is whatever's written on your bag. And make sure the environment down the bottom says part 1 receiver. I've got mine set to sender because I'm going to be the sender. And I'm pretty sure yep. So setting it to 255 should do the job for me. So what you can do now, once you've flashed it, if you got to that point, I'll wait for everyone to get to that point. But once you got to that point, down here, this little power plug button is the serial monitor. So you can actually hook straight into this and look at the messages coming back and forth. I just want to check. The other thing I'll touch on why we're playing with Platform IO is Platform IO has this ini file, and this is where you actually specify things about the project specifically. So like when we go to the serial monitor, it's going to actually use this baud rate. I just noticed it actually says COM6 here, so it's going to try and force COM6 onto me. My baud is actually COM5 on this computer, so I'm actually going to delete that. On your receiver code, did I leave it in there? No, I took it out of the receiver code, so it's all good. So again, make sure this down here says part 1 receiver. For you, mine's the sender, obviously. Make sure yours is part 1 receiver, and then just hit that little power plug, I guess. So what I might do is I might try and go. So you're on the. Because what I can do is someone got their code running, and I'll try and send it to them directly. No, the other way. So mine's the sender. And I'm using my button here, and I'm just, sending messages to all the other nodes. I'm 1. Oh, really? Oh, yeah. I don't think that matters, but.
All the emotions in this. What was that? That's my brain.
Eric, you getting anything this time? Yeah, I don't know. I have to look into that. Definitely was the high risk element of this, the broadcast hall. No dice. It'd be something there's something in the configuration of the radio that's I think you have to enable for maybe broadcast hall. But the more interesting thing I was going to get is to get everyone to sort of pair up and do it. But it'll be more interesting to do it with the gateway example. But I can. So I've been able to hit yours. Everyone I've been able to hit individually. See how quickly I can see if I can get an answer. So yeah, if you pair up, so one of you is the sender, one of the receiver, and you can do point to point, just switch the IDs around. And then to actually do the sending, you've just got a short pin 3 to ground. That's like a button press. It's a bit, yeah. I actually had it. I actually didn't think it was working at all. So the interesting thing is, the sender actually doesn't even do. It doesn't do anything. It like and I think it's in the code there. Puts it to sleep fully if you don't have any other receivers live. So I was like flashing it and like pressing the button and nothing was happening. I couldn't figure out what was happening for ages. And then eventually I just turned a receiver on and all just started working. But yeah, there's not much happening. It's pretty hard to actually tell what's going on. But through the serial monitor is probably the easiest way to know it's running. If that's open and it said listening at 43 megahertz. Low cost was one. The ability to sort of easily program it in VS Code and stuff was another big advantage. Good documentation and library support. I've got mine running actually. I just realised why people might be having troubles. I'm receiving information. So I had all the things you probably get from most micros, but the big one was the ease that you can basically program these and use these little RFM boards, the radio chips on them. So the first time I ever came across this was basically trying to automate the house. And I didn't want to connect 20 different devices straight to my Wi-Fi router. So I started looking around. I just wanted to create my own low-cost wireless sensor network and easily program them. And this sort of these things came straight to the top. Basically the ability to set up a whole bunch of nodes, all talk back to a gateway, and then that be the only point of connection for the internet actually being the gateway, rather than have a whole bunch of Wi-Fi devices in the house that are all, sort of their own gateway, so to speak. But yeah, I guess the Spark nodes are the reason that I really like them, is the ability to easily program them, and the fact that they're low power and you can set up your own wireless networks, sensor networks with them. All right, we'll have a crack. Should be reasonably self-explanatory, but I will go through it. Nodes and gateways, and this is back to that concept, that picture I had a bit earlier, where we're actually this is probably a more practical use for these from an IoT perspective. Is you're gonna have a bunch of nodes all filtering into a gateway, and then the gateway is the conduit between the ground and the cloud, the real world and the internet, so to speak. So just this example, very straightforward. In their project, I've got a part 2 node. You're going to flash that. I will show you some things that we need to change before that happens. So this is the code for the node. Looks pretty similar. Again, I am going to be the gateway. So my ID will be 1, and I have 1 on my bag. So no one will take 1, because if you read your bag and set your node ID to whatever number's on your bag, we will be good. But make sure your network ID is 100, which it's all in the code. So the only thing you have to change is your node ID. So set the node ID to whatever node number is written on your baggie. And notable things about this code, the transmit period, I've got it defaulted to 5 seconds. You can tweak it. Basically what's going to happen is when you activate your nodes and I turn on the gateway, every transmit period in milliseconds, a string is going to get sent. And we're going to see it. You should see it come on hopefully on my serial monitor. The string that is defaulted is here. You can change that if you want, I don't mind. Obviously node 2 only applies to node 2, so probably for clarity you can change it, but I'm going to show you what actually gets displayed on the gateway in a second. But yes, this is the node code. Again, it's got the little blinky function just to make the light blink. This does have a couple, so when you open the serial monitor, you can tweak some of the settings. So if you actually enter a number between 0 and 9, it'll change the transmit period from 1000 to 9000 milliseconds. It does have these other things that these are sort of just come through the template code, pressing R, D, E, do different things. They're more related to the flash chips, which aren't actually on these boards, but I didn't remove it. I didn't gut it out of this one. I got it out of the challenge solutions, but I just left them in there. They're part of the examples. And the receiver, again, pretty straightforward kind of stuff. If you get sent a message, it's going to tell you about that message, who it came from, what was the data, RSI value of the sender. You're not going to get anything on your nodes because I'm not going to send you anything. You're all going to send stuff to me. But the most interesting part for you guys is this part here. I put the asterisks around. So every transmit period, effectively, it's going to run this code where it gets the length of your payload, which is that string you declare that constant at the top, and send that. If it sends successfully, it's going to say okay, and if it doesn't, it's going to say flash send failed. That should just be send failed, but that's pretty much, this is the critical part of the code, more or less. So what is going to happen on my end is I'm going to flash my one with the gateway. So same sort of deal. I'm going to set my node ID to 1 because the gateway ID will always be 1. Network ID 100. Blinky. Some flash setup stuff doesn't need to be in there. I did gut it out in the challenges. And the most important part is whenever I receive something, I'm going to print the ID of the node that sent me that, and then the payload and the RSI value. And if an acknowledge has been requested, I'll send back an acknowledge. So let's have a go. So if you've got your board there, if you haven't already done so, change your environment setting down here to part 2 node, and then flash that to your Motino board. I'm going to do it with my gateway 1. And I should be able to open my serial monitor. And we got some messages coming through. Node 4564236. So we're missing 7.
Ban that guy. Kick him off the network. How dare you not?
Start filtering out those specific nodes.
Strength in conformity.
Yep. 2, 3, 4, 5, 6. So I think 7 or. No, just number 7 or something. So yeah, if you've got it and you want to have a crack, if you're in your serial monitor, if you just put a number like between 0 and 9, it should start coming through a bit quicker or slower depending on what you put.
No ASIO surveillance teams? No FBI surveillance vans? No? Is there any difference hardware-wise between
No. No, just the code that I flashed on it. Yeah, right. So yeah, you could flash like a great test, right? Is you can actually go in, like I could stop this, you could flash the gateway, and you'll start getting all this information. Yeah. Typically, so when I've set these up for things, like the home automation stuff, the nodes, I won't use the USB versions. I'll use just basically the version of the chip you can buy without the USB connector. So you program it with a special programmer, but they're much cheaper because they don't have that hardware. And then my gateway will be the one with the USB because that'll be hooked into a Raspberry Pi or something like that.
How do you program it?
So they have like pins on them, and there's like a no, just an FTDI adapter. So they look like that, and you just plug them in.
You plug that in, and then you plug a USB.
And you plug a USB into this. Yeah. So that's like the USB part. So it's not built onto the board.
That's cool. And then it saves it on the memory.
Well, it just saves the cost of the board. Because a lot of these, like you program them once, set them, forget them. Yeah. Its job might be just to read a temperature sensor reading and send it, and you don't do a lot of updates on it. Yeah. But it's also not interfacing with anything other than what's coming through the I/O pins. If it does need to interface with something that's not coming through the I/O pins, then you get the USB one. Yeah. But the short and long of it is either one of those could be the gateway. It just depends on what code you put on it.
Yeah. And then how do you connect this one?
Hey!
I'll check out that board. Are you just spamming him?
Yep. Spamming my poor little gateway.
6.
I think you can just, if you got the serial monitor open, you can just hit like 0, or you could just hit 1 and it'll come every second. Or you can obviously go in and update the hard coded to something even faster. So that was that. If you're in that node code I was sort of showing you guys before, there's just a little switch case. If the input's greater than 48 or less than 57, so they're the ASCII values for the 0 to 9 keys, then it converts that ASCII value into an actual number, times it by 1,000, and sets that transmit period. If it equals 0, then it makes sure it's at least a second. No, I don't know off the top of my head.
How are these talking to each other, Kim? Is that like a Wi-Fi kind of?
It's just like a. I mean, it's just like a radio, like a 433 megahertz radio chip, and there's just an underlying library that's basically handling a lot of the sending and receiving, acknowledging, managing the time windows that it is publishing it and all that kind of stuff. So what I set up for next, and I'll leave my gateway running, is I had a couple of challenges, and you can pick whichever one you want. But if you can do challenge 1, then challenge 2's a pretty small step. But I don't think either of them are too difficult. The challenge 1 was, can you modify basically the node code? So rather than sending a fixed string, you actually type in a message and hit enter, and it pumps it over. So if you wanted to have a crack at doing that, I thought that would be a bit cooler than just sort of sending constantly a constant payload. So effectively, the hint is, you can already see there's code here for reading the serial, and basically what you want to do is store the bytes that come into some kind of buffer, and then only send if the enter key is pressed. And I can and then challenge 2, if you want to, it's pretty much the same concept, except write some code, 1 bit of code that you're going to put on 2 different Motinos. So same code, 2 different Motinos, basically create a walkie-talkie point-to-point chat sort of thing. So challenge, I've sort of set up the blank projects for you. So challenge 1, main.cpp, you can sort of go from there. I won't talk too much through it, but I'll start attacking it the way I solved it. Buffer size. Gut all this out. So, fix.
Yep, those houses are
Did notice if you are using the challenge one as the template there for your mains at CPP, the COM port is in that one as well. So it might be trying to flash to COM6.
What is their challenge?
It's just a blank. It's just an empty project. You're welcome. Yeah, you're welcome to modify the node one. It's pretty much what I did. I just copied the node code in and modified that. So yeah, I should be able to. So because I have that in there, if I go challenge one. Let's put that. So Make that a bit cleaner.
Brian, this is following that really on receiving. Yeah, so you take him.
Oh, yeah, that makes sense. That's okay. So actually, if I put what's the null character? If I put 0. It's better. So now if I change this to gateway. So what I might do for the gateway is naughty, naughty, naughty. All the comments. I don't want you to use comp6. I want you to use port. So just to stop the gateway being spammed, I just changed the gateway node to 20. There's a few of you. I was like, people are probably trying to debug this and like, oh, there's my message. Oh. Ooh. That explains that. Right, you should start, as long as you set your gateway to 20, you should start seeing them come through. And obviously, if you want hints or if you're sort of trying to figure out how to get somewhere it is, you can go onto the GitHub. If you go onto the GitHub page and switch the branch to solutions, you can then go straight in and have a look at the challenge 1 and 2 they've filled out. Because you would have seen there, so there's obviously code that like, oh, if you press R, it does something. If you press D, so you pretty much want to, every key press you kind of want to put into an array and then keep track of the index of the array. So put the character in and then increment your index. So the next time we can put the next character into the array and so on and so forth until you get to enter, which is, it's carriage return followed by line feed. So as a test case, right, to get your code working, you could actually just do it so whatever character comes in, it just sends that character.
That's what I'm doing now.
So if I go back to the node code, for example, like a basic way to maybe get going could be simply say, all right, you go down to this code here. This is the sendy code here. Pretty much the only part you care about really is this part. Even strip it down to that. And you could actually have it, so you just copy that. Up here it reads some input. Let's just paste that in there. The length is going to be, I think it's in bytes, is it? I think it's in bytes. And we could literally just put the input in. Oh, once a char, okay, once it is a. Well, I was talking, there's no meat lovers. But I was. Was there? Was there? Yeah. Okay. They just get demolished first. Probably. Yeah. So I did this one, Matt. This was just like a simple test where, so literally at the top here where it does the input serial read, there's probably a simpler way to do this, I think, with pointers, but I just jammed that character into a char array, and then I just sent it, and that just sends a button press.
Does it come out as a
Four passenger asks, "What are you coding?"
So the Spark nodes is they're little Motino boards. They're basically Arduino clones with little RF modules built into them. It's really good for low cost sort of IoT. If you want to create a little local network of sensors all talking to each other or all communicating to a gateway. And probably more of an explanation. I don't know if we can share the GitHub link maybe. Got the README on there. I'll leave this at the top of the screen a bit. So that's it there. It's one of the things I realized in my solution, which I fixed just now. So a cool thing you can do. Let me go to my one I just wrote. So this one that I wrote now is basically what I wrote earlier. Setting the buff index when it is a command R. So I got command R or command N. So because it sends both, and what this does is if buff index is greater than 0, because both go through, it'll detect one, and then the next character will be the other one of those things. So it ignores them if the buff index is greater than. It only does things if buff index is greater than 0. But I can also set the buff in the last thing in the buff index to 0, that's a null character. So that actually tells, what I'm actually telling it there is there's a buffer of so many characters. The end of the string is where that null character is, because and then I print that, and what that means is it only prints literally the last few things typed. So if you omit that, if I type the word test and then print the buffer, and then the next thing I type is hi, it'll print hi st. So by putting the 0 in on the end, it's saying the end of the string is after the I, and then it'll only print the I.
Oh yeah, that's what I was doing. It's like, why is this printing like artifacts from a previous string?
Yeah.
Actually, in this case,
All right. Well, that's the end of that. I don't know if I've still got anyone hanging on the Teams, but if you join late or if you want to, this will all be on the YouTube, right? The YouTube stream will be saved to the Blast Furnace channel straight away, and
on Twitch or on Reddit, or on Facebook even, whatever your poison is.
No worries. See you next time. That's the GitHub link if you sort of come in late or you just wanted to recap. It's got everything that we sort of went through and all the source code.
Oh, we're peaking at 12. Peaking at 12 people. Is that link in, can you send that link to me in Slack so I can put it in Reddit?
Yep. I can do that. So yeah, this will all be on YouTube if you do want to go back and watch it. Otherwise, that's it.